Hello and good morning. We've got a lot to cover today, but rather than bury the lead, I'm just going to tell you up front, we're going to be talking about whether or not an intelligence explosion is coming, what the data says and what Sam Altman says, and what other constraints might exist. So we're going to be covering Sam Altman's blog. He just published a new blog post. We're also going to be covering research that was just published by Epoch AI, which is actually just looking at the raw data about what's happening and what's coming. And then finally, we're going to be talking about other constraints other than intelligence. And when I say constraints, I mean constraints to economic productivity and scientific progress, because those are kind of the two main KPI, or the two main factors that a lot of us have settled on in terms of measuring the impact of artificial intelligence, because it comes down to dollars and cents, and it also comes down to scientific progress, and that translates to number of papers published and also the quality of papers published, and then finally how much the magnitude of those papers, like what is the intellectual contribution, because many scientific papers, if they only move the needle by 0.01%, it doesn't matter quite as much, because then you need hundreds of papers to move the needle only 1%. All right, anyways, you get the idea. So first, Sam Altman published a new personal blog, and there was a lot of kind of starry-eyed, hand-wavy, vague promises. For instance, some of the stuff that he talked about was like, AI advancement will accelerate human capabilities dramatically. Let's see, what was another one? Unprecedented prosperity and superintelligence will be achieved soon in as few as 1,000 days. But I filtered out all the wheat from the chaff. I was like, okay, just what is the actual concrete claims or assertions that he's making here? And there's only about 5. So one prediction is that Sam says that AI will be personal assistants. Okay, cool. We're already working on that, so that's not really, anything special or new. He talked about, we'll have personalized education, which, being in the ed tech space and having a lot of friends in ed tech, yes, that's coming. We're working on it. Royal we, not just me, and not me specifically, but there's a lot of people working on bringing personalized education to all levels of education, by the way. Another thing that he said is that jobs will be changing, but they'll be changing more slowly than some people expect. Let's see, the fourth concrete thing that he said is that we will need unprecedented amounts of AI infrastructure. That means compute and energy, which everyone knows and agrees with. And then finally, scaling has been effective. So this is an observation. He said it, kind of very poetically, which is, there's only 3 words that matter, which is deep learning worked. Now, one thing that raised some eyebrows is he said that we'll have super intelligence. You can measure it in the thousands of days. Which, okay, cool. So that could be anywhere up to, 1,000 days, 10,000 days, whatever. And by the way, I might sound flippant, but I do agree with him. I do agree that kind of the new numbers suggest that AGI 2025, superintelligence 2027. But then it's still a matter of deployment and scaling and economies of scale. And there's still a lot that's going to happen. And we'll talk about that. So moving on to the Epoch AI stuff. Now, if you're listening to this, I'll do the best to describe the graphs, but the way that I described it to a friend is it's straight lines on a logarithmic scale. If you've seen one graph, you've seen a million, just like this. So, but the point is that there does not appear to be diminishing returns yet. And in fact, on Epoch AI's number 1 chart, their number 1 graph, let me just describe this to you. And if you're watching this on video, you probably are seeing the graph. But they charted out the amount of flops, so the training compute on AI going all the way back to 1951 to 2025. And so for the first few decades, from 1951 to 2010, the amount of training compute used on AI and machine learning went up 1.4x per year. So even on a logarithmic scale across several decades, that was 1 times 10 to the 4th. So I guess that's if my math is correct, that's 1,000 flops back in 1951, all the way up to 2010, where it was 1 to the 12th. So I think that's a billion. So we went from 1,000 to 1 billion over the course of 6 decades. But then in 2021, the graph changes direction, and instead of 1.4x per year, it goes up to 4.1x per year. So this is the deep learning era. Now this observation, which is, this is a durable trend over the last 15 years. So if you've listened to me for any length of time, you know that I'm a big fan of data. And if you have concrete data, trust the data. So when you see these straight lines on a logarithmic scale and they just keep going, that's kind of a durable sign. So this research publication, they have plenty of other graphs, but let me just kind of summarize kind of what we're seeing. So number one, training compute is doubling every 6 months. So that's that 4x per year. So training compute going up 4x per year or doubling every 6 months. Training costs are doubling every 9 months. And so at least for frontier models, they did clarify that for the largest frontier models, training costs are doubling every 9 months. Now you might wonder, okay, well, if training compute is doubling every 6 months, why aren't costs doubling every 9 months? This goes back to something that Jensen Huang said, the CEO of NVIDIA, where, I don't know if he said it, but this is the data, the same data that he was looking at, which is we are getting economies of scale. When you build larger data centers and larger clusters, you do get some energy savings, and you do also get some other compute and networking benefits that allow for more economic scaling. Another thing that they observed is that scaling for language is scaling faster than vision. And I think the reason for that is just that language has much broader utility. It can write code, it can, read logs, it can do all kinds of stuff. It can write API calls. So being able to master language, which includes programming languages, it just has more economic utility than just vision. So it's not scaling much faster. It's like 1.2x faster or something. But still, language is scaling faster than vision, which is that was not surprising to me, put it that way. Like I saw that and I was like, okay, I'll just include that as a data point. Let's see, the amount of data doubling for training runs is doubling every 8 months. So that's doubling not quite as fast as compute, which is really interesting. Training time, interestingly enough, is only going up 1.2x per year. So it started in 2010 about 1 day for a training run, and now it's about 100 days for a training run. So you still get those compounding returns, that compounding interest rate. So 20% per year CAGR, compound annual growth rate, it still goes up pretty fast. So right now in 2024, training runs are about 100 days. And if that continues for any length of time, it could be 1,000 days, 10,000 days within 10 or 15 years. And then finally, the power required is also doubling annually. So not every 6 months, it's doubling every 12 months. So we are seeing lots and lots of exponentials, lots of straight lines on logarithmic scales. This research is all by Epoch AI. I'll make sure that the link is in the description. You should look at the graphs. They're very pretty. It's very well presented, but it is also a very, very compelling and comprehensive view that, yes, we are scaling up, and whether or not scale is all you need, we're certainly getting the scale. And finally, I want to talk about other constraints, because, okay, yes, all evidence agrees with Ray Kurzweil. You look at Moore's law over the last 7 decades. You look at the growth in AI compute. You get another exponential on top of the underlying transistor density. So we have exponentials on top of exponentials, which is what Jensen Huang said with Moore's law squared. So there is more data, there is more evidence to support that we are kind of in this condition of Moore's law squared, where even if the underlying transistors might not be doubling quite as fast as they used to be, certainly the 6 to 9 months for the AI models doubling, that is true. But then also you look at the total amount of compute available. That is doubling every 6 months. That means that the chip fabs are printing chips as fast as they can. And not only that, every subsequent generation of chip that they produce is 2 to 10x kind of what the previous generation was in terms of total utility to training artificial intelligence. So we do have I'm not going to say a preponderance of evidence, but we do have a very compelling argument. There is the data to support that an intelligence explosion is coming. Now, a lot of people say, oh, well, how do you control that, and so on and so forth. And I can talk about why, there's not really, I've talked about it before. I don't really see a compelling argument that we're going to, quote, lose control of it. It is something that can have volition, but the TLDR is it is a grievous mistake to engage in anthropomorphic projection, which is basically to ascribe human-like motivations to an AI. And then people might say, well, we're not assuming human-like motivations. We're assuming that it will come up with its own goals. But even the concept of goals is still human anthropomorphic projection. So anyways, moving on. The way that I think of it is a language model is just a new CPU. It's just a new type of processor. On its own, a language model is harmless. It doesn't really want to do anything. Yes, it can do harmful things in the same way that a CPU can either be used to show you YouTube videos, a CPU can also be used to run military training, and a CPU can also be used to steer a nuclear missile. Dual-use technology is scary. Electricity was scary when it came out. So, that's kind of my take. Now, let's talk about the actual economic and scientific constraints here. You might, Sam Altman and others, they get this like far away, starry-eyed look when they talk about this future that they're going to create that is utopian. And by the way, I do agree we are heading for utopia, but it's not going to be as cut and dry and straight simple as they would like you to believe, or as they seem to believe themselves. So here's an example. What are the primary constraints to the frontiers of scientific research? I picked two experiments to prove a point. One is the LHC, the Large Hadron Collider, and the other is the James Webb Space Telescope. Intelligence was not the primary constraint on these frontier scientific experiments. It was money, it was time, it was energy, and it was materials. Even if you have, a million PhDs with an IQ of 250 working on these projects, yes, they might have gone a little bit faster. They would have still been extremely expensive. They still would have been extremely slow. They still would have required a tremendous amount of energy and material input. And so it basically comes down to entropy as the enemy here, matter and energy. Even if you solve intelligence, every industry is going to have other constraints. And I've tried to slice and dice this at a bunch of different ways, like looking at it like per sector, like let's look at transportation, let's look at communications. And what I ultimately have done is just kind of gone down to like first principles, like what does the math say? When you look at all scientifically valuable human activity, when you look at all economically valuable human activity, yes, intelligence is a significant constraint in many domains, but it is not the most significant constraint in most domains. And so, for instance, let's take energy. So whether you're building nuclear reactors or solar panels or nuclear fusion or whatever, yes, artificial intelligence will absolutely help in some respects. But at the end of the day, a lot of this stuff is just boots on the ground, deploying solar farms, rebuilding nuclear reactors, and then, of course, researching nuclear fusion, which intelligence probably would help accelerate nuclear fusion research. But even then, when you need to do those big, heavy experiments, it can still take many, many years to build a test nuclear reactor. And so then when I basically, it comes down to matter and energy, and then also time and space. This is actually, I got the best results, and this is another reason. Let me just do a quick aside. People have asked me what I think about OpenAI's O1, and under most circumstances, it's still not as useful as Sonnet. I took this experiment to ChatGPT, and it gave me, some really basic ideas, and even with some pushback and like badgering it to try and be more useful, it still just wasn't very helpful. But with the right prompting, that was honestly much simpler prompting, Claude was able to provide a very, very good first principles view of what are the scientific and economic constraints other than intelligence. So it comes down to matter and energy and time and space. And then also entropy. So, raw materials, heavy materials, rare materials, those all figure into the constraints. Then entropy. So entropy is biological processes, the biosphere, economic processes, human processes. the speed of light, gravity, the amount of usable space to do some of these things. There are plenty of constraints other than intelligence. So even if we had AGI tomorrow, then without the robots, now granted AGI will help us make better robots, but even then it'll take time to build the robots because you need to build the factories that build the robots, and then you need the materials to build the robots. So you see what I mean is that there is always a constraint. This is the law of constraints, is that no matter what it is that you're trying to do, whether it's a problem you're trying to solve or an economy you're trying to accelerate, or science that you're trying to do, there is always a constraint. And yes, it is entirely possible that within 1 to 5 to 10 years, somewhere in there, intelligence will no longer be the primary constraint, but there will be plenty of other constraints. And, not the least of which is going to be the political process. It's going to be the human process. It's going to be human frailty and stupidity and just really basic boneheaded stuff that's going to slow this down. And this is the reason that I'm driving all this home, is not to be like a wet blanket, but it's just to point out that like we do need to be thinking about other constraints. And so, for instance, just if you want to focus on achieving super intelligence, right? Which I think that'll happen. The market forces are aligned, the incentive structures are aligned. So super intelligence is going to happen, whether we push for it or not. The primary constraints are data, energy, and compute. And so guess what? They're working on all of those. Microsoft is going to fire up a nuclear reactor on 3 Mile Island. Sam Altman is investing in nuclear fusion. People are planning on building the largest energy hungry data centers. So all of those problems are being worked on, but they are also constraints. Data is one that is, once you've consumed all the data and then you kind of ruminate on the data that you've got, there's still only so much that you can do with self-play. At a certain point of time, you need to do the experiments, right? Like they said in Oppenheimer, theory will only get you so far. Eventually, the rubber needs to meet the road, and you need to actually get into the lab and do some experiments to actually generate useful new data, useful new information. You need to build the test reactor to get the useful data, to get the useful information. You need to put the telescope in space to get the useful data, to get the useful information. So kind of what I'm saying here is that expanding the sphere of useful human knowledge is often very slow and very expensive. And AI is going to bump into the boundaries of having consumed all useful human knowledge before science can proceed. Now, that being said, within that bubble of human knowledge, there is still a lot you can do. If you know everything that there is about material science and computer science and theoretical physics and so on and so forth, sure, that can help you make all kinds of useful new products. And for many people, they don't really care about the frontier of science. It's more about what gadget can I get, which is where you end up with kind of the more cyberpunk mentality, which is like, let's just get meds that can cure any disease. Let's just get some cybernetic implants. Let's get some cool VR going. And all of that is going to be economically valuable and economically useful. And it's also going to be interesting in terms of our life. And then also, to take a step back, what I'm talking about is like, the intelligence explosion. Even if there are these constraints, it looks like AI is going to surpass most humans either, this year or next in terms of intellectual capability. And then robots are not that far behind. Robots are only, commercially scalable and commercially useful robots are only 2 to 3 years away as well. So even long before we get to, artificial superintelligence and, a post-humanist future, it looks like we're all not going to have to be working before too long. Now, to what Sam said in his blog post about how jobs will be changing more slowly than people might expect or might hope, I do kind of agree with that. And this is something that I've been exploring a lot through post-labor economics, and whether or not, we're going to be entering into a new economic paradigm, and whether or not there will be a demand for human labor. There's going to be a lot of challenges to this, but I think that we will get to kind of an automation cliff. So if you haven't heard of this term before, I used to call it the automation paradox, but there's an other stuff that is technically an automation paradox. which I think the original definition of automation paradox is like the more you automate, the more that there is to automate. Basically, as your automation skills get better, you find more things that are automatable. But the automation cliff, I think, is a little bit more accurate, which is as long as there is something for humans to do, there will probably be more work for humans to do as AI and robots take off, because the AI and robots are tireless, meaning that whenever they get stuck, they're going to be waiting on humans. However, there will be more work for humans to do up until the last minute to where the AI and the robots take over that last function. And then there will suddenly be nothing for humans to do. Now, this is a prediction. It may or may not be true. If the amount of human labor, the demand for human labor goes up exponentially for the next 5 to 10 years, and then it drops to zero suddenly, that could be cataclysmic for, economic and job stability and that sort of thing. However, reality is never that clean cut. It might happen on a job by job basis. So for instance, call centers, they're falling off a cliff, but I think specific individual jobs will fall off the cliff one at a time. And there will almost certainly be some job dislocation, some creative destruction, where yes, like call centers might go the way of the dinosaurs, but whether or not there's a commensurate amount of new jobs created, the answer is probably not. Whenever I look at the data, some people say automation created 15 million jobs in the last 20 years, but automation also destroyed 30 million jobs in the last 20 years. So automation is at least over recent data, and again, remember, I trust the data, automation is generally a net loss of jobs. Let me do a quick Perplexity search. Let's see, is automation a net loss or gain of jobs? In other words, does automation create more jobs than it destroys? It's been a while since I've looked up this data, and Perplexity didn't exist last time I looked it up. So I don't want to lie to you. So let me see if there's some evidence. Based on the available research and expert opinions, the impact of automation is complex and nuanced. Okay, so it's not going to give me an answer. Let's see. World Economic Forum suggested that by 2025, automation will create 12 million more jobs than it eliminates. Let's see. Historically, technologies have tended to create more jobs than they eliminate over time. And so one example is the internet created millions of new jobs comprising around 10% of the US GDP. Okay, so it seems like right now, at least based on this consensus, that automation does generally create more jobs. Goldman Sachs estimates that AI could increase global GDP by 7% in the coming years. And that increased GDP, they're assuming that will translate to new jobs. But I don't really buy it. Time will tell. Waiting for the data, kind of as my mantra there. All right. Anyways, this episode is getting a little bit long. I think you get the idea. I'll make sure that everything is in the show notes in terms of the Epoch AI and the Sam Altman's blog. Real quick from me, just a reminder, I've got my New Era Pathfinders community. We're going to be focusing on 3 frameworks. So the 3 frameworks are, number 1 is TLC, so therapeutic lifestyle changes. This was a framework pioneered by Roger Walsh. It is an 8-point framework that if you follow that framework, you will be happier and healthier. We're also focusing on Rupa, which is reduce worry, understand impact, prepare for changes, and then align accordingly. So that is specifically how I am adapting to the changing landscape due to AI. And then finally, systems thinking. And systems thinking is something that I have refined over a 15-year IT career and then a 4 or 5 year now AI career. So systems thinking is how I've done everything that I've done, including building my YouTube brand, my AI research, and all of the above. So it's a very useful framework. And then lastly, my novel Heavy Silver is out. It's available on Barnes & Noble. You can look up the website at heavysilver.net. Thanks for listening to the end, and I will talk to you tomorrow. Cheers.